Okay, in this next video in the Module 2A series, I'm going to continue to review and supplement content from Chapter 5 of your textbook, which is focused on short-term and working memory. But in this particular video, we're going to continue looking at the modal model. I'm going to focus on sensory memory. So you might remember from my last video that sensory memory is basically just a memory store or structural feature of the modal model, which is responsible for taking a brief snapshot of all of the incoming information that is acquired through the senses. So its functions are to capture information via the senses for further processing in short-term memory. So again, it's that snapshot function so that you have access to all incoming information that you can process further in short-term memory if you want to. We'll see in just a second when I talk about persistence of vision that one of the main functions of sensory memory, or one of the main artifacts or byproducts of sensory memory, is that we can connect our sensory experiences. So like I said last time, we can talk about 3 different sensory memory stores. We can talk about iconic memory for visual information, echoic memory for auditory information, and haptic memory for tactile or touch-related information. Okay, so just like your textbook describes, persistence of vision is simply the continued perception of a visual stimulus after it is no longer present. So kind of the classic example of persistence of vision is if you, and I wouldn't necessarily advise this, but if you have a sparkler and you sort of move it back and forth and make all kinds of shapes, you know, like a circle and so forth. The reason why you can do that, why if you wave a sparkler around it leaves this trail of light, isn't because the light itself is still present, but rather because your sensory memory has held the image of the light in mind, or continued to hold the image of the light in mind, even when the stimulus itself is gone, or the light itself has already disappeared, basically. So the sparkler's trail is the classic example because you can move the sparkler back and forth really rapidly and it still looks like this continuous trail of light, but it's not light in actuality. It's simply your mind continuing to perceive the light even in its absence because of your sensory memory. Okay, another example that illustrates persistence of vision and how our sensory memory helps us to connect our sensory experiences is in the perception of film, right? So whenever you watch a movie, you see a continuously moving image, right? But in reality, there are 24 different images projected per second, okay, by a film projector. And each of those 24 images that are projected per second are going to be separated by a dark screen, basically, that's created whenever the shutter of the projector opens and closes, or when it closes, excuse me. So essentially what is happening in reality is you see the first image, right? The first picture is projected, and then the shutter closes and moves the film to show the next image, okay? So you see picture 1, an interval of darkness as the shutter closes, and picture 2, right? But what your mind actually perceives, or what you see, is picture 1 as it's actually projected, your sensory memory or brief snapshot of picture 1, and the next picture, right? So because of our sensory memory, we're able to perceive many, many static pictures as one continuously moving image. Okay, so iconic sensory memory had been discussed for many, many years, but the first person to actually formally research iconic sensory memory was George Sperling, and he conducted his first experiments on iconic sensory memory in 1960. And essentially what he was trying to establish is what is the capacity of sensory memory, or how much information can we hold in our sensory memory. So the way that he did this is, if you were a participant in one of his experiments, you would look on a computer screen and you would see, first you would see a blank screen or a totally white screen, and then you would see a plus sign in the middle of the screen called a fixation cross. And that basically tells you where to focus your eyes. Okay? So you would see a fixation cross, and then you would see this array of letters for just 1/20th of a second, and then it would disappear off the screen. So again, you would see a brief array of letters and for about 1/20th of a second, and then you would be asked to report how many of those letters you saw, or what those letters were. So you would basically be given a test, right? So write down as many of the letters as you saw that you can remember. And what Sperling found is that people had a lot of difficulty with this task, or they couldn't remember a lot of the letters from the array. So there were 12 total letters in the array, and people could only remember about 4.5 items on average, which corresponds to about 38% of the image. Okay? So with these results, at least sort of at first blush, what they suggest is that the capacity of iconic sensory memory must be really, really small, right? We must not be able to hold very much information in our sensory memory at one time. However, a lot of people were reporting to Sperling that they could still see the scene even after it disappeared off the screen. So even after the screen turned white again, or the array disappeared, people were saying, well, I can still see the image, okay? But they could only see it for a very, 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 very brief second or fraction of a second. So essentially what Sperling conjectured is that essentially when we see an image, right? So if I were to show you this image of a flower, what you see in your iconic memory is that, but faster, right? So essentially you see the image in its entirety, but it decays or disappears so rapidly that you're not able to adequately report what you see or what you saw because there's not enough time, right? So Sperling thought, well, what could be happening is people see the whole array, but it decays or disappears before they have time to report it. And when I say disappears, it disappears from their sensory memory, right? Because in order for something to be held in mind, like we just saw in the modal model, right, you have to pay attention to something. Okay, so again, George Sperling, 1960, believed that we could see more than we could report, right? So the limitation is not storing the information. The limitation is having enough time to report on what you see, right? So how did he solve this problem or demonstrate or support his theory? Well, he created a slight variation. So the first experiment that I told you guys about was the whole report procedure, where you just see an array of 12 letters and you're asked, tell me all of the letters that you see, or all the letters that you can remember seeing, right? So in this case, we would have the same fixation cross to tell our participants where to look. They would see the same display for 1/20th of a second. However, they would also see a tone, or hear a tone, excuse me, and this tone would tell them which row they were responsible for reporting, right? So instead of being asked, okay, report on the entire image, tell me all of the letters that you remember from the whole array, right? They were told to report all of the letters in the first row, or all of the letters in the second row, or all of the letters in the third row. And which row they were responsible for reporting was indicated by this tone, right? So they would see the fixation cross, they would see the entire array for 1/20th of a second, the array would disappear, and then they would hear a tone, and if they heard a high-pitched tone, that would tell them report row 1, a medium tone, report row 2, and a low tone, report the last row, or row 3. So what were the results of this experiment? Well, participants were really good at reporting the entire row. They were able to do this quite effortlessly. But why does this matter? Well, it matters because it suggested, it mattered because of what they were able to do. So the most important part of this is that participants could report 3.3 out of 4 letters regardless of which row they were asked to report. And remember, if I go back, right, to the previous slide where I showed you the procedure, they weren't told which row to report until after the array had already disappeared, right? So if they had a very limited storage capacity in sensory memory, right, if they could only remember 38% of the array because that's all they had stored, then they should have difficulty across all of the rows, regardless of location, right? They should have a very limited pool in their memories as far as what the array was. But they could report any of the rows regardless of location. So what that suggests is they must, at least initially, have access to the entire image, okay? It's just that the entire image is forgotten very quickly, right? So because they could report 3.3 out of 4 items on each trial regardless of the location, this means that the entire image must be stored in iconic sensory memory, if only for a short time, right? Because if they had only stored part of the image, then they wouldn't be able to report most of the row, 75% of the row, regardless of location. Okay, So what other evidence do we have in support of the idea that people are able to store the entire image in their short-term memory? Well, another experiment that Sperling conducted is he varied the time between the disappearance of the array and the onset of the tone telling them which row to report. Okay, and he varied it from 0 seconds to 1 second. So in the 0 second case, you would see the fixation cross, you would see the array, and then if it was 0 seconds, while the array was still on the screen, you would hear the tone telling you whether to report the whether high, medium, low, this is the row that you should report. Whereas if there was a 1 second delay, you would see the fixation cross, the display would register for 1/20th of a second, and then you would wait a second, and then you would be told, you would hear the tone telling you which row to report. Okay, so this is the data or the results of Sperling's experiment. And he found that with no delay of the tone, they were able to report about 78% of what they were asked. So they were able to report like 3.5 out of 4 items on average for the row that they were asked to report, whether it's the first row, the second row, or the third row. But as the delay increased between the disappearance of the array and the tone telling them which row to report, their performance decreased dramatically, right? And this makes sense if we think about Sperling's theory. Again, Sperling's theory is that initially our sensory memory creates a full and complete snapshot registering the image of the array, but the array is rapidly forgotten, and the only way to transfer it to our short-term memory is if we pay attention to it, right? So if we have to wait really any amount of time between the disappearance of the array and knowing which row we have to report, right, then the task is going to become significantly harder because the image starts to decay pretty much right away, right? So what he found is that they were able to report 78% of the image on average if there was no delay, but this decreased dramatically from 0 to 1 second. And eventually it was just as bad as the whole report procedure, where they're only remembering, 38% of what they're asked to report, which in this case was the whole array. Okay. Okay, so just to recap sensory memory, the capacity is limited only by the amount of info that can be received by the perceptual system, right? So another way of saying that is whatever your ears, eyes, and tactile receptors can register, that information in its entirety is going to be kept in sensory memory. Right? So the capacity of sensory memory is virtually unlimited. Whatever you register in your senses, whether it's visual, auditory, or tactile, that information, at least initially, is going to be registered in sensory memory. The duration of sensory memory, or how long information remains in sensory memory, is much more limited. So as we saw in the previous graph, the length of time in which information in sensory memory lasts, or that image is retained in sensory memory, is about 1 second. With experiments looking at auditory information, duration in sensory memory. It's a little bit longer, so it's between 4 and 20 seconds, which is more analogous to what we would see with short-term memory according to the modal model. And then with haptic, it's about 5 to 10 seconds. So there are other theories of short-term memory that attempt to kind of address these issues. But for now, just know that research seems to suggest that iconic sensory memory has the shortest duration, whereas echoic sensory memory has the longest duration, and haptic memory is somewhere in between. Haptic sensory memory is somewhere in between. Okay, all right, so that is our review, or I guess my review of sensory memory. And in the next video for Module 2A, I will be talking about short-term memory. Okay, all right, so I'll see you in my next video.